Hi guys, I got a special video for you today. I'm going to be talking about paintball ballistics. So for a while I've been wondering if there's a way to calculate the paintball projectile range based on the elevation angle. And of course there is, but it's not easy. So and today we're going to be talking about how I came across some information that kind of helped me in these calculations. And I'll show you some cool devices that I built. So anyways, using your high school formula, you probably know already that the perfect angle is 45 degrees. So if you fire a cannon at 45 degrees above the ground, you'll get the maximum range. Well, this formula only works in vacuum. It doesn't work if there's any air resistance. The trajectory won't be this perfect arc, and the range will be not anywhere close of what it is in vacuum. So the actual ballistics formula include air density, air viscosity, humidity, projectile size, and then tons of other variables, the weight, the initial velocity, the gravity. So they're quite complex, and the velocity of the actual projectile changes over time, and so does the trajectory. If you add spin, if your paintball or your cannonball is spinning, the trajectory will change. As you know, for example, with apex barrels, if there's a backspin on the ball, it stays, the trajectory stays flat for longer. So anyways, I went on a search journey on the internet, and I was trying to find some pre-made formulas, and I found a couple of bits and pieces of information, but nothing that kind of would help me to do my calculations that I wanted. So first of all, let me state that the actual trajectories of paintballs will be something like that. So depends on the initial velocity again, humidity, and so on. But basically, you don't get that perfect arc. Your paintball kind of rises almost in a linear manner, and then as it loses energy, it starts to slope off. I'd say this would be more realistic trajectory, something like that. Okay, so if you shoot at a low angle, let's say this is if you shoot from ground level. If you shoot at from a normal paintball stance and you shoot at 0 degrees, you're gonna see something like this. This distance, if you shoot at 280 feet per second, a typical 2.8 gram paintball, your range here will be about 120 feet, and you can check that on your own, and you will see that roughly matches 120 feet. So the height from which the paintball fired matters, the angle matters, and how do you calculate all this to get this distance based on this angle? So I found some bits and pieces. I found a website of a guy whose name is Gary Derkach, who actually wrote a calculator that calculates the trajectory based on velocity, humidity, diameter of the paintball, the weight of the paintball, and so on. Unfortunately, his website was deleted, so I found some archived copies, but there's not enough. There are some pages missing and so on. I was able to get some data points from there, and I was also able to find some US military ballistics research that came up with these trajectories. So these are realistic trajectories for paintballs fired from about 1.4 meters from a Tipman 98 at roughly 300 feet per second. I think they use CO2, and I don't think actually guns fired at 350. I think they fired lower because the numbers match some other calculations for lower velocities here. So, and the range right here is about 40 meters, which is about 120 feet. So, and this is a 0 angle. So if you fire at 10-degree angle, you get this trajectory, and at 10-degree angle, you get about 75 meters. Multiply that by 3, roughly, you get 240 some feet. So, so I have all this data. I found these pre-calculated values based on Gary's calculator. So at 0 angle, you get 120 feet. At 5, you get 193. Let me refocus this thing. Okay, so you can see the best angle is about 30 degrees. That's the longest range you're going to get at 280 feet per second. There was a 2.9 gram paintball. So as you can see, at 45 degrees, you only get 282. So 45 degree is not an ideal angle. Why? Because of drag, air resistance, and some other forces. This is for a non-spinning paintball, the round paintball. The values here will be completely different for first strikes, and I will be able to calculate them soon, hopefully. So I got all these data points. How do I find the actual formula that allows me to calculate this range for any angle? Well, what I did is I went to a website called wolframalpha.com, which is a computational engine, and I used a function called fit that allows me to fit the data points in the curve. So these are my degrees and these are my ranges based on Gary's calculation from some tables that, well, actually, well, somebody pre-calculated some values using Gary's calculator, because I wasn't able to find the actual calculator online because it's been, like I said, it's been removed. So I was able to get these values, and I got these three functions. I'm using this top one because it matches the data points the best. It's the closest. So these are the angles and these are the ranges. So at 10-degree angle, your range will be about 240, you know, let's say, so is it, sorry, not 240, yeah, 240 feet. You know, at your 30-degree angle, you see you have about 300-foot range. So, and as you can see, this black line is the quartic function, and that actually fits these data points the closest. So, now that I have this curve and I have this function, how do I calculate the actual range in real time? And so I built a device, which is basically an Arduino with an accelerometer strapped to it. This accelerometer only is measuring two axes right now. I was able to convert the output of this accelerometer into degrees and used this function that I found using Wolfram Alpha and Gary's data points to convert the elevation of my gun into range. So the top number is the range, the bottom number is the elevation, and the initial parameters are 280 feet per second velocity, 2.9 gram paintball fired from about 5-foot height. So let's take a look at how this thing works. So the screen is frozen right now because my garage is pretty cold right now. But let's take a look. So let's tilt our gun to, let's say, 15 degrees. Come on, it's really accurate and really sensitive. Okay, so there you go, about 14.8, I get about 272 feet. And let's look at Gary's ballistics calculation. So at 15 degrees, I get 269. My calculator is 272. 3 feet, not too bad of an accuracy. And this thing actually works across the entire range, almost all the way up to 70 feet. So let's take a look at this. So if the angle is 0 degrees, your range will be about 116 feet, 170 feet. Let's go up to 70 degrees. And at about 74 degrees, you can see your range is about 115, 116 feet. So what that means, if you were to fire your paintball gun at this angle, 5 feet off the ground, or at this angle, 5 feet off the ground, the paintball will land roughly in the same spot. Now, the velocity with which it'll land will be different. And I calculated the terminal velocity of a typical paintball, and it turns out to be about 19.5 meters per second or 60 feet per second. And it also happens to be, I'm talking about regular field mid-grade quality paintballs, a 50-50 breaking velocity. So meaning that half the paintballs will break at 60 feet per second, striking a soft target such as your chest plate or maybe your arm. So using this thing, and I can calculate the range, and I can also roughly predict the velocity at which the paintball will be hitting the ground at that range. And this will allow me to determine whether the target is actually worth shooting, because somebody can be really far away, you can pepper them, and all the paintballs will just bounce, unless they hit the mask, I guess. So I was also lucky enough to find the source code of Gary Dirkach's calculator. And if anybody knows who this guy is, and if you have his email, please message it to me over YouTube. I would really like to talk to this guy. I think he did a lot of awesome research in paintball ballistics, and I just have some questions for him. Anyways, so I was able to get a hold of the source code, Java source code for his calculator, and now that I have it, I will be able to rewrite it for Arduino, and this will allow me to enter air pressure, air viscosity, and all the other parameters, paintball weight, paintball diameter, and I'll be able to calculate the range more accurately based on different heights and I can actually use this thing I can't use this for height calculation. I'll have to use GPS module for to calculate the elevation above the ground. I don't know how accurate GPS modules are, but we'll see. That's a future project. Anyway, so this thing will allow me to, if I strap this to my gun and I strap the accelerometer to the side of the gun, so it'll sit like this basically on the Picatinny rail mount. This will allow me to predict where the paintball will land, what the velocity would be, and a whole bunch of other parameters. Anyways, I just wanted to show you this really cool gimmick. The math, I spent 2 days working on this thing, and I'm really excited that I found this information and the source code. So subscribe to my channel, you know, hit the thumbs up. I don't know if it does anything on YouTube, but apparently it's awesome if people do it. It helps the channel. So if you want to hit the thumbs up, that'll be great. And I'll post an update once I have time to rewrite Gary's code, and hopefully I'm snowed in right now, so when the weather gets a little bit better, I'll actually go out into the field, strap this accelerometer to the side of my gun, and test my theory, and test my calculations, and test my Arduino thing to see if it actually works. I'm pretty confident with. Anyways, that's it for today. See you later.